Okay. Okay, so we're gonna get started with just that. Since you didn't get a chance to look at it, we're gonna look at that continuation of the algebra number 8 worksheet. And I think we stopped with what, number 14? Let's see. I think we only had a few problems left. Okay, let's just look at it. Number, I think it was,
Yeah, the quadra, this one,
yeah, well, that one, but I think we stopped with number
it was number 14 we're
14.
supposed to
Here we
do.
go. Yeah, here's number 14. Okay. So there's 14. That's the one Greg is filling a 16-ounce bottle with water. So he fills at a rate and then it leaks at a rate. So if he fills at 1 ounce per second and the bottle leaks at 0.2 ounce per second, his actual rate is going to be the difference between the rate of adding the water and the rate at which he's leaking. So we have to subtract that 0.2 ounce per second from the 1 ounce per second. So we get a net of what? 0.8 ounce per second rate. Is that clear, Latoya?
Yeah.
Okay. I think that's Chastity. Hello,
Correct.
Chastity.
Hi.
Yeah, Chastity's on. We're just getting started. We're finishing up the college algebra number 8. We stopped at number 14. I sent you the explanation. Did you get it, Chastity?
Yes, I got it.
Okay. Yeah, I emailed it. So we're just getting started on number 14. As I just said, the net of filling at a rate and it leaking at a rate is 0.8 ounces per second. That's the rate at which he's filling the bottle. 1 ounce per second adding, 2/10 the leaking, that's the subtraction. So we subtract that and we get a rate, 0.8 ounce seconds is the rate at which Greg is filling his water bottle. So now you can just do a ratio and proportion, or you could just actually, divide the total that he's of the bottle, 16 ounces, by the rate. So the total by the rate, 8 ounces, 0.8 ounces per second. And I just moved the decimal point over 1/6, that's 16 becomes 160. Move it over in the denominator, 0.8 becomes 8. And then when you divide 160 ounces by 8 ounces per second rate, you get 20 seconds. That's how long it would take for Greg to fill the bottle. Any questions on 14?
No.
All right. All right. So that was number 14. Let's go to number 15. Okay. Latoya, you said you didn't get a chance to look at it, right?
No.
Okay. Number 15. Let's look at what we're given. You invest in $18,000 and you're investing it in 2 accounts that pay different interest. One pays 8%, the other one pays 7%. That's the annual interest rate. What else are you given? You're given the total interest earned for the year is $1,300. What are you to find? How much did you invest at each rate? In other words, how much did you invest at 8%? How much did you invest at 7%? So first of all, we give some variables for the 7% interest and the 8%. We said X amount invested at 7% interest. Y amount invested at 8%. And what was the total he invested, Latoya?
18,000.
That's right. The whole total he invested was 18,000 in these 2 accounts. How much interest did he earn?
They said 1,300.
1,300. That's the total interest he earned on that 18,000 in those 2 accounts. Okay, so we have to work with decimals here. We make our percent decimals, and that means dividing by 100 or just shifting decimal point 2 places to the left. 7% becomes 700ths. 8% become 800. Now, since we're given that he earned $1,300 total, that means the amount he invested times a percent is the amount of interest he earned. So for the 7% is 0.07 times X, because we say that's the amount he invested at that percent. But the 8% is 0.08 times Y, because Y is the amount he invested at 8%. And we know that total came to $1,300 interest for the year. You following me now, Latoya?
Yeah.
Okay, Chastity, you following? You're on mute.
Yes, Miss Barbara, I'm so sorry, but
Okay.
my daughter crashed my laptop and it's so hard for me to see on the phone.
Oh yeah, the phone is a small screen. Yeah.
So I'm trying to see, zoom in here and there, but it's kind of hard for me to see. So I'm just
Okay.
like listening.
Oh,
Okay.
okay. All right. Well, I'll be sending you what I'm going over,
All right.
emailing it, and then I'm recording the session.
All
Okay.
right.
So X amount invested at 7%, Y amount invested at 8%. Total invested 18,000 spread over those two accounts. Total interest earned from those two accounts for that amount, $1,300. So the first equation is to take the percent converted to a decimal times the amount earned and do that for both accounts. And that totals the total interest, $1,300. Okay. Now, the amount he earned from X and Y, that's the amount he invested, because he invested a total of 18,000. So the X amount, which is from the 7%, and the Y amount from the 8% is equal to the total $18,000. So those are the two equations. Now, what we can do is we can take this equation and solve for X. That's subtracting Y from both sides. So X would be 18,000 minus Y. And then we can substitute that equation into this equation 1. And that way we'll have one unknown. Okay. So for X, we put 18,000 minus Y. And that's plus 0.08Y. Now we have one unknown and we can solve it. First, we multiply the 0.07 times what is in the parentheses. Remember from PEMDAS. 0.07 times 18,000, we get 1260. 0.07 times minus Y, we get 0.07Y. Plus the 0.08Y that was part of the equation. All right. And that is equal to the 1,300. So we solve for Y, we can add the minus 0.07Y plus 0.08Y is the 0.01, okay? And then we can solve for Y, 1,300 minus 1260 times 0.01 equal 4,000. 4,000 at 8%. And if we know it's 4,000 at 8% and we know the total was 18,000, then we just subtract that 4,000 from the 18,000 and we get 14,000. So your answers are 4,000 at 8% and 14,000 at 7%.
Where you get the 0.01 from, Ms. Barbara?
The what?
Where you get Y equal 1,300 minus 1,200 slash 0.1. Where the 0.1 came
Okay,
from?
I'm solving for Y here, right? So what's
Okay.
a minus 0.07 and a 0.08? That's the 0.01.
Oh, because I was wondering where it come from. That's why.
Oh, okay. All right. Yeah, you subtract the 0.07 from the 0.08, you get the 0.01. And
Oh,
and that would be 0.01 Y. So Y is going to be what? 1300 minus the 1260 divided by that 0.01.
okay.
I kind of condensed it. You want me to write it out? I can write it out.
Yeah, because I didn't understand where it come
Okay.
from.
Okay. All right. Let's just do this. Okay. So if I subtract the 0.07Y from 0.08Y, let me just copy this. And that's the, okay. So the 0.07Y and the 0.08Y, these two Y terms will give you 0.01 because that's a plus, right? So I'll have one plus, I have to subtract 7 from 8 is 1. The sign is plus because I have more plus than negative, right? So this becomes 0.01Y. So this would be 0.01Y. Take out the 0.08. Why? Because I did this, the addition, and then this would be a plus. Okay. Not minus. Okay. So what I did right here, I'll just put what I did. Okay. Combine minus 0.07Y and 0.08Y. Okay, so that's right. I'm adding these two. And so I'm adding, I'll just say add, just use our math terms. Add minus 0.01Y. And these are decimals, not commas. Okay, and that's equal to 0.01Y. Okay. So
Okay.
now this equation becomes 1260 plus 0.01Y equal 1300, right? So to solve for Y, the first thing I do is what? Subtract 1260 from both sides. Okay. So if I subtract 1260 from both sides, now let me just put this all on together. Okay, so I'm on the next side. So I subtract 1260 from both sides. So let's just do that. Copy this over and subtract the 1260. Okay, so this is minus on the left, minus 1260. And then on the right, minus 1260. Okay, so what am I left with? On the left, I'll just have the 0.01Y.
01Y.
That's right. So I'll just have this 0.01Y. And on the right, I will have what you see there, which is 1300 minus 1260. 1300 minus 1260.
260.
Now, to solve for Y, I have to divide both sides by 0.01, right? So
Yeah.
this is the division. So divide both sides by 0.01. So if I do that, on the left side, I will just have Y, correct?
Yeah.
0.01 over 0.01 is just 1. So I'll have Y. And on the right side, let's keep it Y. And on the right side, I'll have this 1300 minus 1260.
Mm.
And that would be divided by the 0.01. Okay, but I'll put this in parentheses because you have to do the subtraction and then do the division. Okay. 1,300 minus 1260 divided by 0.01, which is what we have here, right? Same thing. Latoya, that answers your question about the 0.01?
Yeah.
Okay. Yeah, so I condensed it, but then I just put it exact step by step so you can follow it. Okay. And then once you get Y, then X is just the difference in the total and 4,000. And so 4,000 at 8%, because that's what we said, Y was the amount at 8% and X was the amount at 7%. Questions on 15? Any questions? Okay. Then the next thing we had was 16. Okay, so let's go to 16. And 16, that was the what? The quadratic? Yeah, the quadratic, the general formula of quadratic. AX squared plus BX plus C is 0. Now, A is the coefficient of the X squared and B is the coefficient of the X and C is the constant. So based on this, our A, and I put it right here, A is 2. That's the coefficient of the X squared. B is a minus 12. That's the coefficient of the X. And C is the constant 10. So once you identify your A, B, C terms, of your coefficients of your general quadratic, then you can, this is your quadratic formula. X equal minus B plus or minus square root of B squared minus 4AC divided by 2A. So the first part of this was to substitute the values in the quadratic formula. So X equal minus B, B we said was 12. So that's a minus 12 because it's a minus B and the B is negative. Plus or minus square root B squared is minus 12. So that's minus 12 squared minus 4AC. A is 2, C is 10. So that's 4 times 2 times 10 divided by 2A. A is 2, so 2 times 2. That's the substitution. That's the first part of the 16. Any questions on the substitution?
No.
Okay, so once you define your A, B, C values, because you need those because of the general format of the quadratic. So once you look at your equation, you see where your A is, you see where your B is, you see where your C is. So you substitute A, B, and C in the quadratic, and you have your quadratic formula substituted by the values for your equation. Now, the second step is to solve what are the values of X. That means you take this equation and solve for X. All right. And quadratics always have two values because you have a plus and then you get the amount, and then you have a minus and you get the amount. So once you substitute that in, you can solve for the values. And here is the same equation. We substitute it in, and actually we are doing what it indicates here. The minus 12 squared, minus 12 times minus 12 is 144. 4 times 2 times 10 is minus 80. A minus 12 is a plus 12. So what we have is 12 plus or minus square root, and this square root is really for the whole thing. All right, 144 minus 80 is all underneath this radical sign, divided by 4, 2 times 2. Now, 144 minus 80 is 64. So you have 12 plus or minus square root of 64 over 4. Square root of 64, perfect square root, 8. 12 plus or minus 8 over 4. So 12 plus 8 is 20. 20 over 4 is 5. So that's one of your values. 12 minus 8 is 4. And 4 over 4 is 1. So the values of X are 5 and 1. Questions?
No.
Okay, you follow, Latoya?
Yeah.
Yeah, you just do the math. Yeah, square the 12, multiply, subtract, square root of what's left, and then you add it, divided by 4, you subtract it, divided by 4, and you get the 2 answers. All right, next one was the last one. That was with the tax, right?
Yeah.
Okay. Now, you got property tax for 2 years. And what were you told here? Let's look at what we're given. Okay, 1996, the property tax increased by 6% over the 1995 tax. 1996, you had a surcharge of $200. Okay. So if the Peterson's 1996 tax totaled 2108, and we want to find how much it increased, okay, what we have to do is we've got to subtract that 200 out because that was a surcharge. So the first thing we do is subtract out the surcharge for 1996. So that total tax is 1908. Now this amount is 6% more than the 1995 tax. So that means if we take 6% of the 1995 tax, we add it to the 1995 tax, we should get the 1996 tax. Okay. So if we say X is the 1995 tax, then the 1908 represents that increase, right, of the 0.06%. So 1908 is equal to the tax at 1995 times the increase, 6% becomes the decimal, 0.06, plus the tax for 1995. Then we solve for X. And here, let me just, I condensed this, but let me just add that. 1908, when we add the X, 0.06X plus X, that's where we get the 1.06. All right. So add the 1x here plus the 0.06x. This will give us 1.06x. All right. Just add the coefficients. This is a 1. This is 0.06x. Let me just write this as 0.06x. So you can see it as the coefficient in front of the x. So 1 plus 0.06 gives you 1.06x. Then the next step is divide both sides by 1.06. All right. And if you do that, X is 1908 divided by 1.06. And that gives you the answer of 1800. So X is 1800. So that was the tax for 1995. And if you want to prove it, you can take the 6%, add it to the 1800, and you should get the 1908.
No, that's a lot of money.
What?
So the property tax.
That's not a lot of money.
Yeah.
No, you know, the property tax went up in New York City. And, you know, the borough's tax was always smaller than, say, the Nassau County and Suffolk. But, the, and the tax is based on the assessed value. So property values go up, the tax goes up. I mean, your assessed value goes up, your taxes go up. So
Mhm.
say you bought a house and you paid $300,000. Now, 10 years ago, just give an estimate, you may have been paying $2,000.
Wow.
But now you're probably going to be paying close to $4,000.
Oh.
Yeah, taxes really went up. And it's particularly harsh on Long Island. I had a friend living in Baldwin, Long Island, and her house, she and her husband had paid for their house, but she said the taxes they were paying was like they paying for a mortgage.
Wow.
And they finally moved to Columbia, South Carolina, where she got a brand new house. No one's ever lived in it. It's brand new. And she got that house for like, oh boy, maybe a 1/4 or less of what her house was valued at. And of course she had more space in her house, but the thing is, she, with the children all grown and with grandchildren, she didn't need this space. Plus it had levels, and as they got older, those levels become harder to climb.
Yeah.
So they moved to Columbia, and on everything's on one floor, and she's got I think she's got 2 bedrooms, and everything's on one level. They don't have to step up to nothing. And
That's good.
they had like a 3 levels. She had to even her, you know, these things are nice when you're younger. Like she had a sunken living room, but you got to step down in it. Then you got to go up some levels to the bedroom. So
wow.
And then the lower level, that where she goes into the garage, that's some steps down to that. And that's where she and her husband had their offices. So she was really, really happy. So they sold their house, got a really good buy for it, and bought a house in Carolina, of course, and had money left over they could put away for, to supplement their retirement.
Wow.
Yeah, so that's one reason why some people relocate, because property is less. Of course, like food prices are probably not much different, because food prices are, I think they're high all over. I mean, it's just, I look at my grocery list and when I'm making it up and I say, oh my goodness, what, chicken breast costs $12? I mean, that's, yeah. It's,
But the chicken wing is $15.
Chicken. Oh, let me ask you this, Latoya. Why do you think chicken wings are so expensive?
Because that's the best part of the chicken.
You think so?
No, but that's the only part of the chicken I really like.
Yeah, I like that's my favorite part too. The chicken breast is fine. I can make, like chicken salad from it. But the breast is the wings, I should Google that to see why it's so high. But you know why I think
where I live at, salmon is like $22 a pound.
I like the drums. That's it.
You like the drums?
I like chicken wings, but my favorites are the drums.
Oh, but the one I don't like is the chicken thighs. I do not like.
I never like the thighs.
I don't like the thighs at all. That's the worst piece of chicken as far as I'm concerned. But my theory on chicken wings being so high is because they're used so much by, restaurants and fast food. Everybody's serving wings.
Not anymore, Miss Weber.
What do you mean not anymore?
Not anymore. All the wing spot them, like the holler places them, They ain't got no chicken wing.
What about Popeyes?
Popeye is hard there. You're lucky if you get a wing someplace.
Yeah, but
They don't have it popular anymore.
Popeyes has wings, KFC has wings,
No, the
and they have
Popeyes by me.
wings and things. I think
No,
that's where all the
everything changed. Everybody will usually sell mostly wings. They put on the hip and the thigh now. You ain't getting no pure wings anymore.
really.
Like the halal
Yeah.
chicken, the Kennedy fried chicken, you could have gone and say 5 wings. No, not anymore.
What do they give you? Wingettes?
No, they give you leg and thigh and 1 wing if you're lucky if you get 1.
Oh my goodness.
Even Popeyes hardly. If you need spicy wings, they never have it at all.
Yeah, well, people like that because it's easier to eat finger food.
Yeah,
they
nobody
grab
want
a
a big
wing and,
piece of chicken.
and the drumsticks. Sometimes they so big, I think they inject them with hormones or something.
They manufacture them in a lab.
Sometimes they abnormally large. The legs.
I see some
Yeah.
onions in the supermarket, Miss Barbara. There's no way them onions come from God created earth. We grow onions back home, cucumbers, and them stuff never be huge. Carrots and stuff, tomatoes, okras, and them corn, them stuff never big like that.
Yeah,
They make something huge like where they get them from.
Yeah, the laboratory they experimenting with the food and I don't like it when it looks abnormally large. It's something
Even banana.
Yeah,
Normally
that's
we
true.
grow banana, but guys, when you're buying banana, if it doesn't start with a 4, it's genetic banana you're eating.
Yes.
Yeah.
You have to make sure the first number start with 4.
Okay, now we're starting on our new topic, functions. So let's go to functions. I think I have it out here. Let's see. Introduction. Now, when you hear functions in the real world, what do you think could be a function?
Like it's an input, something that you input.
Yeah, functions are things you have an input and you have an
output.
Sometimes you think of it as a machine. You put in the machine, you get out the machine. So in the real world, give me an example of a function. You input something and you get output.
Yes.
18.
What do you put in?
Your card.
Okay, that's
and then you pump the gas in your car.
That's it. You put in your card as input and your output is the gas you get, right?
Yeah.
Also, you can think of, okay, I put so many gallons in my car and my output is my mileage, right?
Yeah.
Because you can tell if you know your miles per gallon, you can determine how many miles you can go on a certain amount of gas, right? So functions are with us. We don't think of them as functions, but they are functions. There are several things in the real world. We put input and we get output. We put money to buy something. Our input is our money. Our output is our product. We may have a discount, so we put in our discount amount to find out how much we really pay for the item. So functions are not new, right? They're something that's with us and we just never think of them as function. But any kind of thing you think of where I input something and I get output. Think of a vending machine. You want to get some snacks, right?
Yeah.
And you put in your money and what comes out? Hopefully it's snacks. If it doesn't, then you're going to try to beat up the machine, right? because
Yeah, it sucks
eh,
with your money.
yes, okay, so
And
that's
sometimes you're lucky more than one thing drop out because somebody tried to buy the same thing and they didn't get it. So you end up getting two.
Mm.
that's never happened to me. That's
Yeah,
happened to
you
you,
end up
Latoya?
getting two. Yeah, two. What you call it, snicker bar. Because
Oh,
somebody tried
okay.
to order it before and then he got stuck. He didn't come down and then you order it and then because I always beat up the vending machine. So more stuff. Sometimes I get a quarter too. Like
Now
somebody
where
didn't get the
some
change or something.
that happened to me on something in
Yeah.
something. I was getting change or something, and I know the quarters kept coming out. I said, "No."
Yeah,
how
because
was I supposed
somebody
to get
put it
this?
in and they didn't get it back.
Yeah, and I got actually more money than I should have gotten. But you're right, probably somebody had lost money. Okay. Now we have functions and we have relations. Now they are similar in a lot of ways. Now a relation have ordered pairs, but a function, the ordered pairs must satisfy something we call matching. In other words, there should be one for a function, we should have one, we'll just use X and Y. One X value for every Y value, one input for an output. But a relation doesn't have to have that because you can have ordered pairs and you don't have to have the same number in as out. But you must have for a function. Now, two main things about a function, and also about ordered pairs also, is what we call the domain and the range. Remember, the domain is the X value and the Y range is the range is the Y value. The Y value is the output. So you put something in X and you get out Y. Okay.
I don't have this. You
No,
send it out?
no, nobody has this. I will send
Oh,
this
okay.
out afterwards. I'm just going over it. Okay. So what we will be doing, and I think the first exercise I'll give you is one where you recognize whether something is a function or is not. And we'll go through some examples here when the X value is matched with the Y value. Now, we have been using functions, we just didn't call them functions. So the F, what we say, a function F of X right here, function of X. All right. But that's the same as what we've been saying Y. Remember when we had Y equal, you remember this?
MX plus B.
That's right. The only difference, we're not saying Y, we are saying F of X.
Yeah.
M
Algebra and slope and function, they all entwined.
That's right. That's it. So instead of saying Y, we say F of X. So this Y becomes the F of X equal MX plus B. And if you want to find the value of it, you had a value of X, you could solve for it knowing what M and B is. X being the domain, Y being, and the Y is the value that's dependent upon X. Whatever the Y or the F of X is, it's dependent, it's the dependent upon the X value. So the X is independent, the Y is dependent. Okay, so, and it doesn't have to be F, you probably see G, H, I, J, whatever, but normally it's F, and we call that function notation, F of X. And it says other value of F at X, but we don't use value of F at X, we use F of X. And if it was G parenthesis X, like if this was, let's say G of X equal 6X minus 8. All right, that is a function. And we'll keep this small, just like we do with the F. So that's a G. So that's still a function. G of X, which is what we've been calling Y when we were looking at our algebra, is related to 6 times the value of X, that's the multiplication, subtract from that 8. So this X could be a number. Whatever that number is, that's what you put for X. All right. So what does that mean? X, we'll say X equal 3. Latoya, what's G of X if X is 3?
GFS 3.
G of X is related to X by 6X
Oh,
minus
6
8.
times 8.
So-
6 times 3 is 18
Right.
minus 8
And that's equal to what?
minus 10.
Minus 10? A plus
No,
10.
6 times 3, 18. But plus 18 minus minus 26.
No. 6
6
times
3 is
3.
8.
So this would be 6 times 3. Wherever we have an X, we want to put a 3 minus 8. That would be what? 18.
10.
Yes, 10, not minus. 18. Very good. Minus 8 equal 10. So we've been doing our substitution, except now we're doing it in functions.
Yeah.
Okay. All right.
Algebra does all over the place and slow.
Oh, yes, but it all ties in together though. Functions tie
Yeah.
into, and sometimes it's done with the algebra, the functions. Now, how can we represent functions? We can represent functions different ways. We can have equations like we just went through. You can have tables. You can have ordered pairs, independent variable, dependent variable. Remember we said the dependent variable is Y, the independent is X. You can have graphs, you can have mapping, and then you can have a verbal description. In other words, words showing you the relationship with the function. Now, we want to look at some examples. Now, we just did one though, and based on what we just did, see if you can find f of 4. Okay, here's the function. I want you to do this one. Tell me your answer. F of x is equal to 2x minus 5. So we put that there. And I want you to find, I'll just put here, when x is 4. So when we say f of 4, that means where we have an x, we want to put a 4. Okay, so put the 4 where the x, tell me what the answer is. Chastity, what's the answer?
Equal 3.
Latoya, you just changed your name to Chastity.
No, sorry.
I really don't understand.
Okay, Latoya, explain how you got.
So anywhere you see X, you put a 4 there.
Yeah.
So you in the 2 outside, and then you put the 4 where the X is at, and you subtract it from 5.
You following, Chastity?
So you're saying wherever you see an X is a 4?
Yeah, you put a 4 there. That's the input.
Okay.
Yeah, see, f of x, the variable x, 2x minus 5. If I say f of 4, Chastity, wherever, see, I put my 4 here for my x, right? And I have my 2 multiplied by x. So instead of x, I put my 4, 2 times 4.
Yeah.
Then minus 5, 2 times 4 is 8. 8 minus 5 equal 3. You follow?
Yes.
Yeah, just substitute. You remember we substituted for the variable before, but we didn't call it a function. All right.
Oh, okay.
Okay. Now let's take another one. This is the same formula, same equation, and we're gonna do f of 0. Okay. So wherever you see an x, you want to put 0. So that means you put a 0 here. What's the
But I thought
answer?
you.
What's the
Oh,
answer,
there.
Chastity?
Mm,
I want you to finish it. What's the answer?
that's 4 minus 5.
No, where you see an x, you want to put a 0.
Oh, it's not a 4 anymore.
No, f of 4 was here. Now I'm changing my x to a 0 because it says find f of 4, f of minus 6, f of 0, f of a. So I took f of 0. So wherever I see an x, I want to put a 0. So that 2 would be times 0 minus 5. What's that equal to, Chastity?
Mm,
What's 2 times 0?
0,
That's right. What's 0 minus 5?
5.
Plus or minus?
Plus.
No, 0 minus 5 is a minus 5. You don't have a plus here. See, that's 0 minus 5, and that would be equal minus 5. See, I put the substitution on the function f of x, so you see that's going to match what I'll put here for x. So f of 0, 2 times x, where x is 0, 2 times 0, minus 5, 0, minus 5, minus 5. Chastity, is it making sense?
I thought it was always the x, or was always a 4. No?
No, I'm doing, this is 4 different problems here. We did f of 4. All right. Let me take this out. I don't want that. Okay. We did f of 4, and that was the 3, right? Now we're doing a f of 0. Follow?
Yes.
I'm changing the
Wait.
value of the variable. So let's do the f of minus 6. Latoya, you okay?
Yeah, I'm okay.
Okay. So let's put here, okay. Now this is f of a minus 6. I put the minus 6 here. Okay. Now wherever you see an x, I want to put a minus 6. Chastity, my x
Oh.
values are changing. Okay. So now
Okay.
I put a minus 6. Minus.
Okay, got it.
You got it?
Yeah.
Okay. And now that's for the x, and I have a minus 5. So what's that equal to, Chastity?
Hold
What-
on.
What's 2 times a minus 6?
2 times a minus 6.
Mhm.
Is that a positive?
Plus times minus is negative. Remember, multiplication of
Plus or minus?
unlikes give you
Minus.
negative. So that would be
Oh, okay.
minus what?
Is it 12?
That's it. Very good. Okay. Minus 12 minus
Minus
5.
5.
And what's that equal to?
7. And that's
No. Minus minus gives minus. Plus plus
minus.
gives plus. Minus plus subtraction. So what would be the answer?
This is minus 12 minus 5.
Yes. And that's equal what?
That's equals to minus 7. Is it?
No, you're adding. You're adding the minuses. So what would it be?
So minus plus minus is minus.
Yeah, so minus minus. So add the 12 and the 5, you get what?
Okay, wait. I always get confused in this, like, because I thought it was minus 12 minus 5, meaning you subtract.
No, you subtract when the signs are different. These signs are the same.
So it's adding my. Okay, so that's
Yes,
minus 13.
12 and
No,
12,
no,
12 and 5,
17.
minus, that's it, 17. Yeah. See, whenever you have the same signs and you're adding, you're going to add them, whether they're negative or plus. You only subtract when your signs are different.
Okay.
Okay, these are the same. So you got negative, negative. You just got more negative. Okay, that's one way of looking at it. You have more negative. Okay.
Okay.
Now, the substitution doesn't have to be a number. It could be a variable. So let's just take this again and find f of a. Put this here. Now I want,
Mm.
okay, let me put that here. Now this is f of a. So Chastity, what would that be the answer? Wherever you see an X, you want to put an A.
So that's 2a minus 5.
All right, very good. Okay, so you put the 2, the A for the X, so that would be 2A minus 5. Very good. So now you know how to find the value of a function in an equation. All right.
Okay.
Substitute, and it's better if you, when you have this f of x, put the value that you are substituting with the
Yes.
f, and then that value, you know, you've got to put it wherever the variable is. So if you put a 0 here, you've got to put a 0 here. Okay,
Yeah.
if you put a -6 here, f of -6,
Yes.
you've got to
Minus
put a,
6.
yes, right, for the x, you put a f of a, wherever the x is, you put an a.
Got it.
Any questions? So that's clear, right?
No. Yeah.
Okay.
Yes.
All right. So that was for equations. Now we can also be given our function and we
That's finished
define
already?
what?
That one is finished?
No, we're still looking at the equation, but
Oh,
I did it where we're substituting for the variable. But what if
mm,
your function value is given and you define the variable? Find the value of x that makes f of x 11. Okay, so let's go back up here. We're using our same formula. Okay, I'm in equation here. Okay, let's put this here. Okay, now f of x is 11, and we want to find the value of x. That means now we want to put what? Let me just copy this. That means for the f of x, we want to put 11, because it says what value of x makes f of x 11. So 11 then would be equal to 2x
so,
minus 5. How do you solve for x, Chastity? How would you solve for x?
mm,
What would you do first?
you subtract
So what are you going to subtract?
2x minus 5.
No, you want to solve for x. What's the first step you'll do for solving for x?
I'm not sure.
Well, you want to get 11 and a -5. You want to get this on the same side because these are your constants, right? You want to get these on the same side. So how would you get the 5 over on the left side? What would you do to both sides of the equation?
You multiply.
No. How is 5 connected over here on the right? What operation? How is 5 connected to 2x? What operation is this? Addition,
That's
subtraction, multiplication.
subtraction.
That's subtraction. What's the opposite of subtraction?
Addition.
That's right. So you want to add 5 to both sides, right?
Oh God, I wanted to say that I didn't know how to. It wasn't coming out. I was like, oh, wait a minute. I know it had to do
I
with both
kn-
sides.
Yes, you're right. You want to see the 5 is connected to the 2x by addition. So you want to add 5 to both sides. That way you get the constants together. Okay.
Okay.
So let's copy that there. And then we'll add the 5 to the left. And we'll add 5 to the right. So what do you have on the left side, Chastity?
11 plus 5.
And what's that equal to?
That's 16.
That's 16, right? And what do you have on the right side?
5 plus 5
Minus 5 plus 5 gives you what?
minus 5 plus 5. That's negative.
No, no.
20.
Minus and a plus of the same value gives you 0. Minus and a plus of the
Yeah,
same number of variable number combination gives you 0. So what do you have on the right side?
A 0.
That's all you see on the right side? What about your 2x? What are you going to do with the 2x? You can't throw it away.
So you put the 2x there?
That's it. 2x plus 0 is 2x, right?
2x plus 0. Yes. 2x
Yeah, because this
plus
is
0.
minus 5 and plus 5 is a 0. So 2x added a 0 just gives you 2x. So you have 2x equals 16. So what is x equal to? You can do that from mental math. What number times 2 gives 16?
8.
8, right? So x equal 8. Or you could say divide both sides. Okay, divide both sides by 2. And that would give you x, right? Divide by 2. 2x over 2 gives you x. 16 over 2 gives you 8. But you can, at this point, see mental math. You can say, well, it's only one number times the 2 will give me 16, and that number is 8.
It's easier that way.
Yeah, that's right. So when you get here, you don't have to really do that. That's what I'm saying. Because when you get simple numbers like this and you can figure it out, you just put what it's equal to. Okay, so this
Okay.
was one where you given the f, the function, and you define the variable. So the function was given as 11. So that's why I put it over on the left. That's f of x. And now solve for the variable x. So for f of x is 11, x is 8. All right.
Okay.
Now what's 2 times 8?
16.
What's 16 minus 5?
16 minus 5. It's 11.
That's it. So you see it's correct. I mean, you can check it.
Yeah.
When you put that 8 up here,
Yes.
2 times 8, 16 minus 5, and you get 11. Okay, so that was the equation. Now, let's look at some tables. That's another way we can represent functions. Remember I said equations, tables, graphs. Okay, let's look at tables. Now, and after that is mapping. Now this one, okay. G of 1. Now for the 1, you look at X. For the G of the value, you look over here. So what is G of 1, Latoya? She's on mute. Chastity, what's
5.
yes, very good. G when X is 1, G of 1 is 5. Latoya, what is G of 3?
29.
29. When X is 3, this is 29. What's G of 0?
2.
G of 0 is 2. Okay, what is X when G of X is 14? What is X, Latoya?
2.
2. So you can go both ways here. So this is how it could be represented in a table where you look at the values and you can just pick out either the function or the variable.
How did they get the 29 down there? And X is 3. GX is what?
Well,
29.
we don't have the equation they used, but let's just see here. Let's see, 2, let's see, 3, 9, 15, right? Well, maybe you can see the relationship here. From 2 to 5 is a 3, from 5 to 14 is a 9, and from 14 to 29 is a 15. So how are they related? It might be
multiples of 5. Multiples
well, let's see.
of 15.
Well, sometime they're exponents. Okay, so so the first 2 is 3. The next one is 9. See, they didn't give us an equation. Just see if we can figure it out. Okay, that's 9. And that's 15. How are those related?
Like those are the multiples of 3. Like not multiples.
No, that's not it. The 3 and 9 differs by what? 6?
Yeah.
And 9 and 15 differs by 6, right? So 29. So the next number would be what? Well, it's really the difference. So, okay, this was 3, this was 9, this was 15. So the difference between the difference is 6. So if this was, okay. Well, it's definitely not a linear.
Or are we changing things around?
No, we were seeing if we could figure out the equation from the
okay.
table. And I'm not sure we can do that. It's not linear, because linear, they would change the same. You know, in other words, the difference between this value and this one would be the same as the difference between the second value and the third, and then the third, the fourth. So it's not linear because they're not the same. But if you go from the difference and you get the same value, it's a quadratic actually. See, it's a quadratic because if the first level difference are not the same, then you can eliminate linear. If you get the difference between the differences and they are the same, then it's a quadratic. So it's a quadratic. Don't know what it is, but that's a quadratic. Okay, but the key is if you look at it, a table like this, and your differences are not the same, then you say it's not linear. In other words, you plot it, you won't get a straight line. If you take the second difference and you get the same values, then it's a quadratic. All right.
Okay.
Now, let's see. This is this. So the difference here would actually be what? 21. 21 minus 15 is 6. So the difference there would be 21, but we still don't know, but we just know it's a quadratic. All right. So tables is another way of representing functions. Now, let's look at mapping. I want to look at mapping in some example and an example. Okay. Let me go to mapping and put that all on one page. Mapping. Now, this mapping refers to body weight and height. For a man of 5 feet 11 inches, the mapping below shows the body mass index. And the body mass index is a measure of body fat based on height and weight. So this is a body mass index of 18.5 to 24.9 is considered healthy. Now, what you do here is like here, find the BMI for a man who of height 5'11", because this whole thing is 5 feet 11 inches, who weighs 180 pounds. So did you find it? Look at 180 pounds. What does that map to, Latoya?
26.5.
180?
His weight is 26 BMIs. Oh no, it's 25.1.
25.1. 180 maps to 25.1. Okay. Okay. Chastity, if I had a BMI of 22.3, what's the weight of the man?
160.
122.3. That's right. It maps to the 160. So that's how you can use the function in mapping, right? Because you're given the weight and the body mass index, which is a measurement of body fat based on height and weight. So the weight determines the weight and the height, but this table is just for 5 feet 11 inch man. So the weight is dependent, the weight affects the height. So the weight is an input, the BMI is an output. Okay. Now let's go to I think we did this one already. That was the equation. We did that. All right. Now let's go to this table. Find G of 1. Find an X of 1 in your table and read G of X. So I think we did that. Well,
This
no.
is called, what is this called? So is this algebra?
This is a table. This is functions.
Oh, okay. It's not algebra.
Well, it's really technically algebra, but we
Okay.
refer to it as functions because instead of using like the X and Y's, we're using function of, which could be
Okay.
generally it's F, G, H, J, but generally you use F or G, but we can use any letters. All right.
Okay.
Now, G of 1, find X of 1 in your table and read the G of X. So if you find X of 1, that's what it's saying, then the G of 1 is 5. G of 3 is 29. So we went through that. Okay, G of X, if it's 14, then the G of X is 14, and we go across here and the X is 2. Okay, so that's just more examples of the table. And we went through the body mass index where you gave me some values for the BMI for a given weight, or you gave me the weight for a given BMI. Now, let's look at graphs. Graphs, another way of representing functions. So let's look at this one. That's another way of representing functions. So we had mapping, we had tables, we had equations. Okay. So now let's look at graphs. Now, graphs, the X line is the horizontal, the Y is the
Line vertical.
right? Now,
Yeah.
f of 0, now remember that's the Y. When f is 0, find the values of X. So can you tell me what the values of X are? When f of X is 0, when Y is 0, what are the X values, Latoya?
2 and 4.
No.
Minus
Remember,
4 and 4.
Minus 2.
that's it, Chastity, minus 4 and 4. Because when you're on the X line, your Y is 0. And remember the f of 0 is Y. So f of 0 is here and f of 0 is here. What's the value of the X? It's a plus 4 or minus 4.
Minus.
Got it. Very good. Latoya, you see that?
Yeah.
Now, if the point is on the X line, then the Y is 0. So Y is 0 at 2 points, this point and this point. So your answer would be the values of X equal minus 4 and plus 4. Okay, that's the answer. Now, what's the value of Y? Okay. What's the value of Y when X is 0, Latoya?
4.
4, that's right. Because if you're on the Y line, the X is 0, and that's at 4. Okay, Y is 4, X is 0. Now the next one is ordered pairs. Now, you know what ordered pairs are, right? It's a X and a Y, and they're in that order. So if I had this point right here, can you see where I'm putting my pointer? Right?
Yeah, it's 5.
What's the value of X?
2.
2. No, 3.
3.
Well, it could, well, we don't see, we just see a 4. It could be a 2. Well, it could be a 2. Could be 2, 4. Okay, we'll say a 2. All right. And right here, what is
5. No, 7. 7.
Well, it's probably, let's see, 4, 8. It's probably a 6. Like 8 for midway is probably
Oh, yeah.
6, right? So, okay, so we'll say a 2 and a 6. Now, when you write the ordered pair, how would you write it? You'd write it the X first, 2, 6. That's an ordered pair. And they're always in the format X followed by Y. All right. Now, remember we said you could only have an X value with one Y value, not more than one. Okay. And if it's a function, there's one X per one Y value. So if you know that is true, okay, is this a function? Now remember I said the X and the Y, the X, the Y, the X, the Y. is this a function, Chastity?
Yes.
Why you say it's a function? Well, you're correct anyway, because all my X
They-
values, 1, 2, 3, 4, 5, the X values only have one Y value. So this is a function. Latoya, what about this one? Is this a function?
No,
Why?
because some is odd and some is even.
It's not good enough. What else?
Um,
So the odd is like the X.
X, yeah, the
And
X
what
is
followed
odd.
is what the odd is equivalent to X, right? So that's like odd, but the odd is equivalent to X, but does it have one or more Y values? It can only have one now. The odd has a 1 here, it has a 3 here, has a 5 here.
It have more than one Y values. And it's
That's it.
supposed
So
to be even.
it's not a function. No. Odd represents X and the numbers represent Y, right?
Why?
But remember, we said for it to be a function, it can only match one Y value. But if odd represents X, odd is representing 1, 2, 3 different Y values. So it's not a function. So this would be no. And it's just, you said with this one would be yes.
Yeah.
It's a function, yes. So I'll probably give you an exercise for you to do for homework, where I just want you to identify what's a function and what's not a function from the ordered pairs.
I like the other part better, where
What
you
part?
plot.
Oh, that you mean the graph?
Yeah,
Can
no,
you
the
write?
plotting.
I'm
Like where
sorry.
you plot, you get a number, you plot it in.
Oh, where right up here? Yeah. Oh, well, I can give you a graph and let you give me the ordered pairs, you know, like where I put them and put dots on them and you tell me the ordered pairs. And then I
Yeah,
can
well,
ask you when you plot the line, does it represent a function?
okay.
Chas, do you
I
have a question?
I just wanted to know if you could write down why is it a function and why is it not a function?
Okay. It's a function. This is a function because there is only, okay. Yes. Okay. Because there is only one input per output. Okay, there's only one input per output. In other words, the one is the the one is the X, right? That's input. But that one you don't see anywhere else with an output. Okay, so there's
Okay.
only one input per out. This one is not a function because there is more than one output per input. In other words, the odd, which is the input, has more than one output.
Oh, I got it. And this
Yeah.
one odd, two
See,
odd, three
odd,
odds, right?
yeah, and they all and they have different out. So if I have odd 1, that's the input, that's the output. But I have an input again with another output. And that makes it not a function because it's more than one output per input. So odd has 3 different outputs here. Whereas here, odd, I mean, the number has only one input per output.
Okay.
Got it?
Yes.
So I want you to be able to identify those. If I gave you a list of if I gave you a list of ordered pairs, I definitely want you to be able, in this format, if I gave you a list of ordered pairs, I want you to be able to tell me which are functions, which are not functions. Got it? And
Yeah.
they may not be numbers. Like here, it says odd, even, odd, even. So if I give you some, you know, variables or some names, you can, it's the same thing. Just you translate them to X, like X, Y, X, Y, X, Y, X, Y. Okay.
Okay.
Now, we said relations can be ordered pairs, right? So a relation, a function is always a relation, but a relation is not always a function. A function has to have a specific criteria. In other words, one input per output. But a relation doesn't have to have that, right? So now, relation is a function. Why? Because each of these inputs only map to one output. One output. Okay. So that relation is a function because P is an input, maps to M. Q is an input, maps to N. R is an input, maps to N. Now notice both of these are mapping to N, but that's a Y value. So we don't care about the Ys when we identify functions. We care about the input, the X values. They must map to one output. Okay. Same thing here. Relation is a function. P maps to X. Q maps to Y. R maps to Z. What about this one? Reason this one is not a function because P input maps to X, but Q here is mapping to two outputs. That means it's not a function. Q is mapping to Y and Q is mapping to Z. Remember, I told you it's only a one-to-one relationship. This is going to two, Q to Y, Q to Z. Questions? So a relation, just remember this, a function is a relation, but not all relations are functions. So these are all relations, but this one is not a function. Okay. Now let's go to review. A function relation. Each possible input value leads to exactly one output. Okay. We say the output is a function of the input. Now you want to determine whether relation is a function. Look at the input, identify the output. Each input, the one output is a function. Two or more outputs, it's a relation, but it's not a function. Got it? Okay. Now I think we have some real world examples here. Okay. Okay, here's an example. You have class grade rules are functions. You want to determine if they're functions, right? Now, the grade point average a function of the percent grade, or is the percent grade a function of the grade point average? Now, which one is a function of the other? The percent grade, which one is the input?
The percent grade.
Percent grade, you think the percent grade is input to the grade point average?
No, it's the output.
Which one is the output?
The percent grade is the output. And the grade point average is the input.
So you say the grade point average determines your percent grade? Actually, the percent grade determines your grade point average, right? So the percent grade is the input to your grade point average. So your grade point average is your output. The percent grade is your input. So we say the grade point average is a function of the percent grade. Just think about it. When you take in classes, you get an average. What is your average dependent upon? It's dependent upon the A's, B's, C's, whatever, but those are dependent upon your percent grade, right? This at 92 to 100 could be an A, right? And that's a 4-point average. So the percent grade affects your grade point average. So the grade point average, the function of the grade point average, or if you go up here where it says, is the percent grade a function of the grade point average? The grade point average is a function of the percent grade. That's the output, that's the input. What about the days of the month? You can use functions for the days of the month. Now we know days of the month can have what? 31, 30,
30, 29,
29, the leap year,
28.
28. All right. So the output is the number of days in the month. The function is the input, the month. So when it's January, the output is 31. If it were September, what would this be?
30.
Yeah, if this was September, the output would be 30. Okay, the name of the input month is the input to a rule that specifies the number for the output, the number of days in the month. Okay, so those are ways you can represent function notation. Now, as I said before, they didn't have, the functions do not have to be numbers. We put a letter in there. They can be names of people. They can be geometric object labels. Okay. Now, read this, Latoya. Right here.
What does this function represent in words? A function n equal f.
F of y.
F of y gives the number of police officers and in a town in the year y. What does F22005 equal 300 represents?
Now, what does that represent? Just say it in words. What does that represent? N
Like
is f of y. N is f of y, right?
Like
so,
in a town in here, 2005 is it n in a town in here?
That's the year. Okay.
Yeah, that's the year.
Here's the function right here. Let's just copy that. Okay. There's the function, right? N equals f of y. Now, what goes where the y is, Latoya? Using
2005.
This. That's right. The 2005 goes here. Yes, 2005. Okay. And the N is what?
The 300.
300. That's the number of police officers. Okay. So the number of police officers for 2005 was 300. So the 2005 represents the year that the number of police officers was 300. That's what that represents. Questions? So remember we said that these numbers, they don't have to be just a number. They can represent something. Like this represents the year 2005. Maybe 2010, it may have been 325. It had 25 more officers. Okay. So that's an example.
Wow. The only thing we know that function was the FX and the table.
Yeah,
I
but
never
I
even
mean,
know them apart here. Lord, when you think you know algebra come with something else. When you think you know function, it come with something more. See,
yeah,
how
but
far they want to take math to. See,
this is real world though, Latoya. This is real world. The
but ain't
function.
nobody going to college and passing no math, please.
What do you mean nobody's doing the college practice? People passing math.
I with a C.
Well,
That's
that's passing, but
so complicated.
but not everybody needs a high level of math, right? Some
Yeah,
people
that's what I'm saying. Because if
arithmetic.
I show people the algebra where I was doing. They have master's degree and they didn't even know what the hell they were doing. They could even help me.
No, because
Masters and bachelor.
it depends on the major, Latoya. Certain majors you only take maybe one math, and it may not even go up to algebra. So
one was a CPA, Miss Barbara, with the taxes.
Well, CPAs, they do statistics. They normally know, but you know what? They don't really have to know a lot of math. You know why? Because they have software that calculates things for them. They just input numbers.
Well, I need to go to college with a thing where I don't have to do hard math. I'm over this hard math thing. Algebra bust me ass last time, couple months.
Yeah,
no function come.
Me too. I haven't been
It's
able to
like I
pass the
can't
test.
win. I was glad to get rid of word problems and algebra. Now I'm in the same spot again.
I'm getting so like discouraged. Like I don't know.
No, chance. Don't get discouraged. I mean, if you can relate things to the real world, it makes more sense, I think. Because a lot of the math is kind of abstract and it's harder that way. That's why I try to come up with some real world examples.
I'm giving back Catherine Johnson her title.
What? Giving what?
The lady where we take Armstrong from Mars, Armstrong from Mars, however hell we went. I said she was a lady when no math could do math out her brain. I said I wanted to hold the torch, but I giving it back to her. And I said I always want to get my doctorate in math. I think that's funny.
No, I mean it happens, but math has been a challenging subject for a lot of people. And
I never made one person get A in math. I could do a survey and nobody ever get A and B in math. I was like, damn, I don't even stand a chance.
Well, I think
these are people with big degrees.
Yeah, well, some people actually feel defeated before they even started, and that kind of holds you back. You got to open your mind up that I can do it. I may have to do it in pieces, but I can do it. Okay? That's why.
Not an open mind, Miss Barbara. Trust me, I told you I wanted to have my doctorate in mathematics, but now that's a slim chance.
All right,
I didn't want to get it in writing. I want to get it in math. Because I was like, Matt, you're not gonna beat me, I'm gonna beat you back. But shucks, my
All right.
chances are slim.
All right, let's look at some tables. Now look at these three tables. Tell me which tables represent a function, Chastity.
Mm,
You got three tables, table 6, table 7, table 8. Remember I told you that you have one input per output. So tell me which is a function. Table 6, is that a function?
yes.
That's a function. You're right, because the input matches to one output. Latoya, what about 7? Function or not?
No,
You say no?
yeah.
Why? Why do you say it's not a function? It's table
Because
7.
the first one is a negative.
Yeah, functions can be negative.
Oh, I didn't know.
Well,
I didn't know
apparently
the X can be negative
X can be
and the Y
negative.
can be
We
positive.
did one. Remember we did one where I had the negative f of X and X was negative.
Oh, yeah.
You remember? I think it was -6.
Yeah, -6.
Okay.
No, but I didn't see it in the
Okay,
yeah,
so
that's
that
fine.
means, is it a function or not, Latoya?
I think it's a function.
It is, because every X value maps to one output. These are all different. You don't see duplicate X's over here, right?
No.
Chastity, table 8, input or output? I mean, function or not function?
Not function.
That's right. Why?
Because he has two input, two equal inputs,
That's
which
right.
is 5 and 5.
Yeah, you have 5 with a 2 output and 5 with a 4. You're right. So table 8, not a function.
What was 7? What was it?
7 is a function, because notice you don't have any duplicates over
Yes,
here on
okay,
the
got it.
input. Okay. Look for the duplicates. You got duplicates over here. That means you've got an input mapping to more than one output. So function, not a function. Got it?
Yeah.
Okay. You getting it?
Go Chastity.
Oh, thank you.
Okay.
I like how I spaced out.
Yeah, that's okay. Now, f of x, we want to evaluate some functions here. F of x equal x to the second power plus 3x minus 4.
God.
Put x equal 2, tell me what you get. Put x equal a, tell me what you get. So I'm going to copy this. I want you to substitute, tell me what you get. So this first one is the x is going to be a 2. So wherever you see an x, you're going to put a 2. Okay. Do that one and tell me the answer. So x is 2, 2 to the second, 3 times 2 minus 4. The answers?
4.
What did you get, Latoya?
2 plus 4.
What did you get, Chastity? Wherever you see an x, wherever you see an x, put a 2.
A -6.
Huh?
-6.
I don't know if I did it right.
-7.
How are you getting
The
it?
x square plus 3.
Okay. equal. Now, wherever you see an X, you're gonna put
Two.
the 2. Okay, so let's take this
7
and substitute the 2.
is 10.
Okay, so this is gonna be a 2, right?
Yeah.
2 squared. This will be 3 times 2. Okay, what's 2 to the second power?
4.
4. All right, so this will be equal 4. What's 3 times 2?
6.
6, right? And we have minus 4. So what's that equal to?
10.
What is that equal to, Chastity?
10
Minus 10. Minus 10.
minus 10.
No, what's 4
No.
plus 6?
10.
10. So
What's
10
10
minus
minus
4.
4?
Minus 6.
6.
I've been saying
Why you
minus
put
6.
10?
And you say no.
You said it's not a minus, Latoya. 10 minus 4 is just 6.
Oh,
Where are you getting minus?
I don't know.
2 to the second, 2 times 2 is 4, right? 3 times 2 is 6, and then a minus 4. 4 plus 6 is 10. 10 subtract 4 gives you 6,
Oh, Baba.
right?
God help me, Jesus.
How did you get minus 6?
I don't know.
Chastity, you follow?
Why is the minus 4 there?
Because it was a minus 4 here.
Oh, you copy it over. Okay.
Yeah, I just copied the equation.
I got
All
it.
right, there's a minus 4. Then I just combine the 4 plus 6, subtract the 4, and I get 6.
Got it.
Put the A in. Tell me what you get.
What do you mean put the A in?
X equal A.
Oh, so
Okay.
That's it is. Oh,
it's F8.
Okay,
Correct.
so let's just put this, right?
A
F of
square.
A, function of A. That's right. So you put A. That's correct. And what else do I do, Chastity?
That's equal A, what is it called?
Square.
Square 2.
Yeah,
Square 2
there's a
second
A
power.
there, right? That's A. And then what do I put here for the X?
3A minus 4.
That's it. That's it. That's the answer. Wherever you see an X, you want to put an A. So X squared becomes A squared. 3X becomes 3A.
Okay.
Got it? And we'll
Yes.
do the last one. Do this one. H of P is P squared plus T plus 2P. Take this one, wherever you see a P, put a 4. Tell me what you get.
So it's H.
Okay, so I'm going to put that here. And so what do
It's
I get?
4.
Okay. So that would be H, function H of 4. Okay. So wherever
4
I
to the
see a
second
P, I
power.
want to put a 4, right? So this will be 4 to the second power. And what do I put here, Chastity? Wherever P, I put
4.
a 4. All right, so I put a 4 here for the P. And what's that equal to? What's 4 times 4? 4 squared is 4 times 4. No, 4 times 4, Chastity, not 4 plus 4.
16.
16. So that would be what? 16.
16 plus 2.
2 times 4,
8.
8. And what's 16 plus 8?
24.
24. That's correct. That's it. See how you getting it?
So what's up with this Job function using Function word problems already. Oh God. Oh,
That is right.
Okay, this one, I'm gonna have you do it for your homework. I think it's just one. Yeah, it's just the one. No, it's two problems. Okay, so I'll give you, well, two things for homework. These last two problems, word problems, we'll go over them, but I want you to try them. And then I'll give you some equations or tables or whatever in a format, and you just indicate function, not a function. So two things I'll be emailing you.
I'm so
so do we
bad with
get
problems.
this?
Identifying whether something is a function or not a function, and just try these two word problems, okay?
Will you email it to us, Ms. Barbara?
Yes, I'll email it to you. Yeah, so this is gonna be homework, and it's just two problems. We'll go over it, but I just want you to try it, see how you do, okay? And then along with the homework, I said these two problems, plus I'll give you an exercise in identifying whether something is a function or not a function.
Okay.
Remember, it's a 1-to-1. Okay, a one input to one output. If you've got more than one input, mapping to different outputs, not a function. And remember, a relation between input and output can be a function or it could not be a function, but they're always a relation. Okay.
Okay.
All right. So we'll stop here and I will email you this and I will load it to YouTube. All right. Thanks for joining.
You too.
Okay, have a good night.
You too. Bye.
Thank you, Miss Barbara.
Okay. All right. So long.
Bye-bye, good night.
Bye-bye.